So last time within this life cycle, we have given emphasis on the structural part here last time within this. So we have learned what is the role of structural engineer and what parameters are considered while design of any structure. Uh, it may be buildings, it may be water tanks or any steel structures like that. Then what structural engineer is doing in the office and what are the processes involved in the structural engineering from start to end, we can say from architectural drawing study till the structural drawing preparation. So we generally submit the structural drawings to the site for construction. So we have seen these are the outputs of structural engineering firm, like foundation drawings, plain beam drawings, or floor beam drawings. Then we specify the grade of concrete, grade of steel. We give the reinforcement schedule of beams, columns. We even give the details of water tanks, their reinforcement sizes and all, staircase details. And to arrive at this output, we generally do the analysis of the structure either manually or in the softwares like ETABS or StatPro. We also do the design of members like column, beam, footing, slabs, either manually or in Excel program or in the softwares also like RCDC or maybe SAFE. And we also show the detailing of reinforcement in the drawings. So either it may be earthquake detailing or it may be normal detailing as per the IS codes. And we do the structural drawings. So this was the discussion we had last time. And after the structural drawings are prepared, now actually the planning process is over till this part. So if you see this life cycle again, you can see the land survey. It is a planning part which is done in the finally we do the drawing in the office. Geotechnical report, it is also we can say official work before the construction of any site, we can say. Yes, we need to do the some site work, but it is before the actual construction of the project. Then architectural plans and drawings, structural drawings, structural calculation reports. Then there may be mechanical, electrical drawings also available, plumbing drawings. So this is our planning part, total planning part, which is generally done in the offices. And once the drawings are received by the contractors, then they start construction, constructing the structure or building. And we'll go to the construction part then. So after the planning is done, we need to do the construction of the project. So can anybody tell me what is required in the construction of any structure, let's say building?
Labors, material.
Yes. So generally we require team team of laborers. It may be laborers. Then
Material.
Engineer, engineers.
yes, in the team we require engineers also. And as you said, we require material. So material may be, for example, what kind of material are required in buildings?
Steel reinforcement.
Steel or reinforcement, then concrete, then
Aggregates.
yes, concrete consists
Okay.
of cement, aggregates, sand. Okay.
Formwork material.
Yeah, formwork,
Shuttering.
shuttering, we can say shuttering material. In shuttering, what kind of material is there? It may be ply. So in shuttering, actually, it may be ply, it may be steel also, steel props. Okay, there may be steel other members also like angles or like that, angles, channels. There may be steel plates also, plates for slab construction. So there is a we require material also in construction of the building. We require laborers, we require engineers. Then what we require?
Machineries.
Equipments.
Uh,
Equipments.
Yes, machinery or equipments. Machineries or equipments, or we can say tools, small tools. So machinery is like,
Concrete mixers and
okay, RMC
mm,
mixers, we can say. Okay.
vibrators.
JCB.
Okay, JCB, which is excavation, required for the excavation, or there may be poke lane for excavation, and in either in soil or in rock also. Then
Compactors.
yes, there are compactors. So there may be plate compactors or rollers also, roller compactors. Then
कोयले से बिजली बनाने के लिए सबसे पहले कोयले को ट्रेनों की मदद
Excavator.
excavator, JCB excavator, let's say. Okay. We require cranes also for lifting, cranes, right? So these are the big, and then we can say dumpers for shifting of the material, right? So these are the big size of machinery is generally required, and there may be tool requirement also, tools, small tools. So the tools may be drilling machine, cutting machine, or what tools are required?
Steel tape.
Yeah, tapes, okay, all that, tape, auto level, and so on. So lot of machineries at total station, TS. So all kind of machineries, tools, equipments are required for construction of any projects. So we discussed labors, engineers, that is man, material, machineries. What else is required? So these are nothing but the resources required in the construction. And apart from that, we require the drawings actually. Finally, means see on the basis of drawings. So our drawings may be architectural drawings, structural drawings, MEP drawings. So all types of drawings, or there may be some other vendors also, vendor drawings. If apart from these, any vendors are there in the structure, in the projects, like generator, regarding generators, regarding maybe firefighting agency, or maybe other people are there. Apart from this civil work, there may be some other work also, which is required in construction. There may be solar panel systems. Okay, so all these drawings are required actually for construction. So generally, this is the team and the resources which are required for the construction. Now, so who is doing the construction mainly? Or responsibility? Who is responsible for the construction of the project?
Contractors.
Yeah, so there may,
and engineers.
yes, contractors and their engineering team. They are responsible for the project actually. Generally, contractor is owning the, who can say, project. So he's getting the job, he through the tenders generally, and once he gets the jobs, then he appoints engineers, he appoints laborers, and subcontractors and team of, and he appoints suppliers, he appoints machineries and all, and ultimately he is responsible. And regarding the technical part, quality of the work, regarding the civil work especially, civil engineers are responsible in the project. So they are responsible for workmanship or material quality, and assuring the construction is done as per the drawings given by the consultants, as per the specification given in the tender or in the drawings. Okay, so the drawings are given by other structural engineers or other consultants also. So this is in general the responsibility of contractors. Any questions regarding this? Okay, then we'll switch over to the next point, which is structural audit. So in actually life cycle, we have seen. So in this, what we have seen, this part, let's discuss on the maintenance part also. What kind of maintenance is to be done in the buildings? Generally, we need this constructed building is handed over to the society. I think we have discussed last time. So once society takes the charge of the building, then they are responsible for the maintenance of the building. What type of maintenance is there in the buildings? Yes.
Electrical work and plumbing.
Okay. So there may be electrical works. There may be some leakage issues there. See, in building, there is a possibility of leakage. So leakage means we need to do waterproofing, which is a plumbing part actually, something related with leakages, waterproofing or plumbing lines. It is related with this plumbing. There may be issues regarding the drainage, choking of the drainage, and there may be many problems regarding the drainage work also. Electrical, that means, see, generally common areas. Then there may be in electrical, we can say lift maintenance is there, lift maintenance. Then there may be, let's say, painting works, painting. If the painting gets deteriorated, then you need to repaint it again. There may be crack filling. So before painting, we generally do the crack filling. So a lot of activities are there involved in the maintenance. See, all of you know that society people pays the maintenance cost per month to the society. And through that maintenance cost, the society is taking care of all these activities regarding this. There may be some extension of any part or common areas like that. So these are the maintenance activities. And if the building becomes old, let's say more than 15 years or 20 years like that, then we need to go for the structural audit. Okay. Now let's see in detail the structural audit part. Yes, structural audit is generally done after 10 to 15 years from the date of construction, or there may be some stipulated bylaws are available. Either some bylaws are saying 15, some are saying 20, 25 like that. And after 15 years, say 3 to 5 years, we need to do the structural audit after that also. So we can say as the building becomes old, you need to check it after 3 to 5 years. What are the stages in structural audit? Do you know this? What do you mean by structural audit? Anybody knows regarding this? क्या क्या करते हैं इसमें? Basic idea.
To identify defects in the structure.
Yeah, to identify defects in the structure. Yes. So there are steps actually by which we identify. So first see why it is required. So can anybody tell me why structural audit is required? To check the defect, you said, to check the defect. So what kind of defects are there in structures?
Cracks,
Yes, we can say cracks. Check the cracks. Then
Leakages.
leakages. Okay.
reflections,
Reflections. Okay. Yes. Yes. So let's say you have seen some cracks in the building. So what will be your opinion? Why the crack may be forming? What may be the reason of cracks? What do you think so? Just I'm asking you questions. See, for doing understanding the structural audit, actually first structural engineering you should know in detail. So how to analyze the structure, what happens, what is meant by design, why crack gets formed, and what are the reasons for that. So these kind of things are required actually, which we learn in the structural engineering. We will learn in the training programs, all structural engineering structures and their basics. And once you understand the basics, then it is, we can say, kind of postmortem. Structural audit is something postmortem. So problem is there, you see the problem, and then you are trying to find out the reasons behind the problem. And once you understand the reasons, then you can give the solutions to the problems. So it may be cracks, leakages, deflections, like this. So anybody knows why, if you see the cracks, what may be your opinion for the crack?
Characteristic strength of concrete is less than there is a possibility of cracks in the structure.
Yeah, there is. So see, there are two types of cracks actually. One is non-structural crack. Non-structural means we can say cracks in plaster, cracks in paint. So which doesn't cause any structural problem. So there will not be harm to the structural safety in totality. It will not collapse, or it will not even crack in that case. So non-structural cracks like plaster or paint. So you need to first observe, is it a plaster crack or paint crack in the paints? Then you can say, okay, I don't have any issue with this. But there may be structural cracks also. So structural cracks means you should know the reason. I'll just give you example. Let's say there is a beam and there is a load onto this. Okay. And last time we have seen that when there is a load on the beam, then it gets bent and it gets deflected, then there is a tension here at the bottom. And if there is no sufficient reinforcement provided, let's say you are not having sufficient reinforcement, or you are not having sufficient depth of the beam, either it may be beam slab, whatever. If there is D is less or reinforcement is less, then what happens? And there is a possibility that your concrete grade is also less. Then there is a possibility of cracks formed here at the bottom. Where there is a maximum bending moment, you may see that there are cracks. And say structural cracks, how you will understand? First, you will see that the structural cracks are in the maximum bending moment zone. And you understand that by structural engineering philosophy. And their crack width is more than 0.3 mm. Greater than 0.3 mm, even 1 mm also may be there. So if there are very wide cracks, then you can say that it is a structural crack. And then you need to give the solutions for that. So you can identify that. So identification of cracks, then if there are leakages, all of you know that due to leakages, there will be corrosion in the reinforcement. So you should do the waterproofing or remedial measures. Then there should not be any excessive deflections, which causes problem to the serviceability. So you can measure the deflections also in the structural audit. So generally how it is done, we do the, so first we'll see what are the reasons of doing this. So if there are cracks, leakages, deflection, there may be problem to the structure. So we should identify that. For that we are doing the structural audit. Then we have to check the current strength of the concrete. See, at the design stage, let's say I have given grade of concrete as M20, say 20 years back. And if I check it today, then the grade is, let's say, M15 only at this point. That means there is a loss of 5 Newton per mm square grade strength, or we can say grade, we can say got reduced by 5 Newton per mm square. Then we need to check whether this is sufficient or will there be any structural problem to this. So to check the strength of concrete at current state, see, then to check overloading of any member. See what happens, all of you know that in buildings, we design the buildings for live loads. Okay. So lie loads means, let's say for kitchen or living room, we take the lie load as 2 kilonewton per square meter. Toilets 2 kilonewton per square meter. In staircase, we take 3 kilonewton per square meter. In rooms, general rooms, I am talking residential rooms, lie load is 2. Let's say somebody is converting that bedroom into storage room. Okay, so what happens? Generally, storage is having, depends what kind of storage is there, but generally the load is 5 kilonewton per square meter, storage load. So you are putting, say you have designed your bedroom for 2 kilonewton per square meter, and you have changed the bedroom into storage. So you are putting more load, let's say 5 kilonewton per square meter. That means there is a overloading of that bedroom, and due to that overloading, the slab will have more load, then the corresponding beams will have more load, and there is a possibility of structural failure or structural cracks into that. So you need to check that, and that is nothing but to check the overloading of on any members, okay, than assumed in the design. So I have assumed in design 2, but now it is the different case. So there are possibilities in that case. Then to check whether there is any deviation of use, that means, let's say, as I said, bedroom converted into storage room, so it's a deviation of use. Then one more overloading case, all of you know that in buildings, we have seen that there are balconies actually involved, like this. This is a cross section. I'm just putting the drawing, and this is a balcony, and this is a railing, we can say railing or wall, parapet wall is there, and this is a balcony portion. These all, let's say this is your second floor, third floor, fourth floor, like that. And this is a balcony. See, many times what happens, these balconies, the people, what people do, they enclose the balconies. So in the beginning, let's say 1.2 meter was the height of the wall for balcony, and after the building we hand over to the society, then flat owner may enclose the balcony. So he's putting wall over here, additional wall, and he's using this balcony as a room. So he's converting this balcony into room. So let's say if it is a living room, and he may feel that my living room size is very less, so why not to enclose this balcony here? So I will use this 1 meter or 1.5 meter, and my living room will increase. And so for that, what he is doing, he is just enclosing by putting additional wall. And what will happen due to this case? क्या होगा इससे? क्या होगा ऐसे हमने किया तो, मतलब फ्लैट ओनर नहीं किया तो
more load is coming over.
कहाँ लोड आएगा ज्यादा?
Oh, 1.2 meter parapet means
Yeah,
there,
so-
there.
Yeah, we were having wall load of 1.2 meter. अभी ये हम जो फ्लोर का लोड हमारा समझो 3 मीटर है, टोटल फ्लोर 1.2. So let's say our total wall height is 3 meters. Okay, so ये 1.2 meter का लोड 3 meter का लोड हुआ height का. So what will happen? That load, where that load will go? This wall load will go where?
Cantilever slab.
Yeah, so either it may be cantilever slab, but mainly we put actually beam here. ऐसे generally beam provide करते हैं हम. We don't put, this beam is there actually below this. Generally we don't allow the this loads on the slab itself, cantilever slab. Better to put beams. So generally beams are provided in the balconies. So this beam will have overloading. Okay, and that means their reinforcement provided and size of the beam provided may not be sufficient to take the load of this 3 meter height. So we need to check this. So this is also a deviation of use and overloading of this beam. So in audit, we generally find this kind of any problems regarding this use. Then there is a possibility that if the building is old and so much of deterioration of concrete is there, so much of corrosion of the reinforcement is there, then it may be possible that the structure is not fit for human use and you need to evacuate. So we should put the notice in front of the building that the building is not safe and please evacuate the building as soon as possible to avoid any mishap. Then structural audit is done to provide any retrofitting solutions. Retrofitting solutions means strengthening solutions. If the beams are not having sufficient capacity, if the columns are not having sufficient capacity, then strengthen them. That means do the retrofitting of the structure, and to suggest any repairs to improve the life of the structure. So we can suggest them, if there is a corrosion of reinforcement, please do the plaster, do the painting, anti-corrosive paints, and or there may be some problem leak. If there are leakages, then you can tell them do the waterproofing to avoid the further leakage, like that. So all these, so the leakage, crack repair is a, we can say, non-structural measures, and retrofitting is a structural retrofitting. So generally there are two words used. One is repairs and second word is retrofitting. Anybody knows what is the difference between these two words? Yes. Repairs का मतलब क्या, retrofitting का क्या? Hello.
In retrofitting, we use reinforcement and concrete to make the sections bigger.
Yes, yes.
But in repair, maybe like painting, plastering.
Yes,
like that.
it may be painting, plastering, it may be waterproofing, it may be crack filling, like this. Okay, so this is general repair, we can say. So it is not giving any, we can say, direct benefit to the structure. Direct benefit I'm talking, because it is not going to increase the capacity of the members like beams, columns, slabs. But yes, it will help for the durability of the structure. Okay, so it is helping for durability and further problem to the structure, but it is not a structural strengthening. It is not adding any capacity to the structure. Okay, but in retrofitting we are adding the capacity or increasing the capacity of the structure. Increasing capacity of structures means capacity of members like beams or slabs or columns, footings. So we can increase the so capacity means what kind of capacity? Either the capacity for gravity loading, or it may be for earthquake loading also. So we can increase the gravity capacity of the members, or you can increase the earthquake capacity of the members or building, we can say. So it should take more gravity load, or it should take whatever earthquake loads are there on the structure. So this is the difference between the two. So we generally give the suggestion of repairs also and retrofitting also generally in structural audit. So this is done, and what steps are there in structural audits? So there are general 3 steps. There are many other tests also. One is the visual inspection. So visual inspection, as I said, what we do in visual inspection, we observe the cracks, we measure the cracks, thickness means thickness of crack, and we even categorize the cracks into non-structural cracks and structural cracks, as I told you. So for that we should observe this. So it is an indirect. We are, see, all of you know that there is a term cause and effect. So all of you know this cause and effect. So there has to be something is, if you can see, let's say there is a beam. Okay, I'm just to understand the cause and effect. What happens? Again, cause effect. Okay. So let's say you are seeing this. Visually, you are seeing this. What do you see here? What is your observation here in this beam? What do you observe? Hello?
Deflection.
Yeah, you are observing the deflection, that it is bending or deflecting, let's say. Okay. So that means, and why it is deflecting, what do you think? What may be the reason of deflection?
Due to loading.
Yes, due to load. So generally we know that any structure, and if you see any deflection, primary reason for that is nothing but a load. Okay, so load is the reason and deflection is, so we can say who is the cause in this? What is the cause?
Load.
Cause is load.
Loading.
Yes. Load is the cause, and what is the effect?
Deflection.
Right? Yes, so generally, whenever you do the audit of real structures, you see the effect first. You see the effect directly. So effect may be deflection, it may be cracks. You may see the cracks also. Structures में crack भी दिखते हैं ऐसे, isn't it? You see the cracks. So crack is also effect, isn't it? This deflection is also effect. So effect may be crack, effect may be deflection. Whatever you can see through your eyes is the effect. Now, once you understand the effect like cracks or deflections and all, then you can think of what may be the cause of it. So you need to see for that also. So in visual inspection, we are seeing the effects first. You see the effects, you observe the effects in visual inspection generally, like crack. Or you see the deflections also, actually, deflections. So these are the effects. So to observe the effects, you are doing this visual inspection. And once you do observe the effects, then you can rethink, brainstorming to understand what may be the reason of cracks. Do the reverse engineering. So understanding the loads, understanding the other any causes are there of these points. Okay. Then visual inspection is first point before any audit. Then we do the testings. So there are two main testings. One is non-destructive testing and one is destructive testing. So in non-destructive testing, we have rebound hammer and we have the ultrasonic test. And in destructive testing, we take the sample from the real structure, actual core, and we do this test, core testing in the lab. So checking the concrete grade of that concrete core. So these are the actually important tests which are done in the structural audit. And then fourth one is there may be chloride attack, sulfate attack test like this, which are causing we can say environmental effect, we can say. So there are many other tests, but these three tests are very much important from the structural point of view: visual inspection, NDT, and core test. So rebound hammer, generally it is used for the surface strength of the any member, surface grade of concrete, surface only, not surface strength. Then there is a ultrasonic pulse velocity test. Generally it is based on the velocity. So there are actually, we are passing the rays through the members, and it is checking the quality. It is a qualitative test, we can say, general condition of test. Qualitative test means general condition of concrete. General condition. And then third test is nothing but the core test. Here what we are doing, we are taking the actual core. So generally the core size is we can say 3-inch diameter, and let's say it may be 125 120 mm length. So it may be 125 mm length and 75 diameter cylindrical core, we can say. And we extract this piece and test in the lab. And we get the grade of the concrete. Then once we do these tests, we actually audit. So you got the grade of concrete. Let's say this column, you get the grade of concrete. Once you get the grade of concrete, then you can reanalyze the building. Okay, so what we do, so we are doing the reanalysis of the building. Reanalysis for actual loads and for actual concrete grade. समझो अभी after the structural audit, we got the concrete grade as M15, let's say. See, previously, before 25 years, let's say it was M20, but now it is M15. So do the design for real concrete grade, which is available now. So you are doing the analysis of the building for actual loads. So there may be overloading also, like storage room or that enclosed balconies. So do the analysis, get the bending moments. So all of you know that what we get in the analysis, getting the bending moment, shear force, axial force in the members, like column, beam, slabs. Actual loads, all of you know that we are knowing that after this audit, and get these results and use this result for the design. So actual design, we can say. Actual designs means I mean to say design for actual forces which are currently in the structure. Okay, and you are doing the actual design for actual grade of concrete and actual these bending moments which you got from actual loads. And after that design, if you feel that some members are failing, see, many times you will see that the buildings are still looks okay. Even though there is overloading, you may see that the building is okay. But see, if some members are failing means they don't follow the IS code. So if you use IS codes and if you design the members, there is a possibility that the member is not sufficient to take the load as per the IS code clauses. In that case also, we say that the member is failing. Okay, so it is not necessary that it should collapse. It is not necessary that it should crack very high. If it doesn't follow the IS codes and there is a really fundamental issues, then we can say it is failing and we should give the retrofitting solutions. So this is the way we do this structural audit. Anybody has done any retrofitting or anybody knows about retrofitting? कैसे करते हैं?
graniting.
Yes.
Using graniting process.
Let me give one example of retrofitting just for timing. Simply, what happens? Let's say you have done the structural audit of the building, and due to the, let's say, the load here which is coming here, let's say 1000 kilonewton. Okay, how you understand the loads coming on the structure? Through analysis. Yes or no? Where you get the loads? Through analysis. Once you understand that this column is having 1000 kilonewton load, and let's say your column size is 230 by 300, let's say. Okay, and there are, let's say, 6 bars in this structure currently. And once you design this column for this load, you may feel that this size is not sufficient, and even reinforcement is also not sufficient. So what can you do? Definitely size is not sufficient. So let's say for this actual load, your size requirement is, say, 400 by 600, let's say. Okay, and you require, instead of 6 bars, you are requiring, let's say, 8 bars. 8 bars of 16, and currently the bars are 6 bars of 16. that means you need to increase the cross section. So how to increase the cross section? Generally, there are
Jacketing.
methods. Yeah,
So by
column
jacketing.
yes, so column jacketing methods are there, where what we do, we are confining the existing column size. So we are putting additional concrete here, and we are putting the additional reinforcement also. I say we are putting additional stirrups also. So previously it was like this, now you are doing like this. Oh. So what you are doing, you are increasing the size like this, ऐसे करते. And then you are putting additional steel, let's say like this. Additional steel, additional concrete area. So your concrete area got increased, your steel got increased. That means your capacity got increased. So these are the ways the structural retrofitting or is done for the columns. We call it as a column jacketing. This can pass through this also. We drill here, actually we create opening here for that. And it depends where you want the strengthening. If you want, it can go even below also. So this is nothing but strengthening for gravity loads. There is a possibility of seismic retrofitting cases. So where the building is not taking earthquake load, so we can do the seismic retrofitting also. So in seismic retrofitting, we generally provide bracings, additional bracings we can say, or we can provide shear walls, additional shear walls. And we can, as a material, either we can use steel or we can use concrete also. Okay, so any material we can use, and you can do the seismic retrofitting also. So to understand the whole process of the structural engineering, structural audit, you should understand the basics first. We are going to take that basic sessions so that you will understand what is done. And once the retrofitting, as I told you, if the building is not, we can say, if the building is very old, like 70 years, 60 years, and the condition is very bad, even though you think of doing the retrofitting, the cost is very high. So you may feel that it is better to demolish the building and do the redevelopment of the structure. So you will demolish the building and you will again do the construction of the new building, we can say. So it is better to do the demolition at the end of the life cycle. So this was the life cycle, whatever we have learnt. Let's see responsibility matrix actually in the life cycle. So see, generally the land is owned by the clients. Okay, so land is with the client. And geotechnical investigation, generally it is done by the geotechnical engineers. All of you know who is geotechnical engineer? What is the qualification of geotechnical engineer? Yes.
MTech in structure, MTech in geotechnical, geological.
See, MTech is not compulsory for doing anything. B is enough. So civil engineer, I would say. Civil engineer is there.
But
Geotechnical. For
college-
land survey, who is doing the land survey? He is also civil engineer mostly. Okay. Who is doing the architectural planning?
Civil engineer and architecture.
Yes, it may be civil engineer or it is a architect. Mainly architects are there, but okay, civil engineers also can do. Structural engineering, who is doing the structural drawings and analysis design? Who is doing this?
Civil engineer and
He is also civil engineer. Who is doing the construction?
Civil engineer.
So maintenance, there may be civil engineer or there may not be. Or it depends what kind of maintenance activity is required. But yes, there is a possibility of civil engineers involved here also. Structural audit,
Structural engineer and civil engineer.
yeah, civil engineer, but he should know the structural engineering, which is very important. So the person who is doing the structural design can do the structural audit. Okay. So as we are also doing the structural audits also, we do the structural design, drawings of new structures, and we do the structural audit of old structures. Retrofitting, it is also structural engineer, which is nothing but civil engineer. Demolition, there may be some special agencies in this case. So you'll see that within this life cycle, we are having a lot of opportunities in every area. Either it may be survey, geotech, architectural, structural, construction, audit, and so on. And in our training program, we are much focusing on this area. So this is our major area of focus. So we are covering much of the things here in this line. And if you want, see, we will take some basics actually of the audit. We will tell you a few sessions only regarding these two areas to understand the concept. But for doing this, you need these basics. So this is applicable over here. So if you want to do these two things in future, you can apply this knowledge here. And you should know the basics of architectural planning, geotechnical investigation, as they are the inputs for us, contour survey. So they are the input for the structural engineers, and their structural engineering drawings, it goes to the site for the as output. These are inputs, 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 and these are the outputs. Okay. And that's why we need to understand everybody here. So we will focus. So this is our core area in the training, core subject, we can say. So we'll go in details of the structural framing, analysis, basic concepts of structural engineering, loads and load path, and so on. Then we will see the basics of analysis, either manually or using softwares. Then we will do the basic design manually and with softwares. Then we will prepare structural drawings, everything. And for that, enrolled in this structural department, which is a core subject in our training program, which is structural department. So the people who are in multinational companies or in local consultancy firms in the structural engineering, you can have the job opportunities in this area also. But yes, this is only not sufficient. You should know this other part also, basics of this. So I think in our IPD program, we have shared that IPD objectives. So you'll see that IPD objective, there is, we have used the word as appreciation. The appreciation means basic knowledge, appreciation, basic knowledge of this, and detailed knowledge of this is very much essential. So that's why we are focusing on this area, because you will be master in one structural engineering part. But whenever you want to become master of any subject, there are some allied knowledge which is required also. It may be construction allied knowledge, audit, or it may be this part. So we are learning the core. So whenever you, what is our field? Structural engineering. Okay, our field of subject. Structural engineering is our field. So there will be one core study of the structural engineering, and there are some allied studies. Allied knowledge or study, we can say allied knowledge. So we have divided the training program in these two parts. So core study means, core knowledge means structural engineering knowledge. So this total will become our IPD, initial professional development part in our training program. Then we will do the, say, real practical application on the projects and so on. Now we will start with the core part, core knowledge, and in core knowledge we should know the basics of structural engineering. So we are going to start with the basics of structural engineering in upcoming sessions from next session. Today we will just have a general discussion on that regarding the basics. So we have completed this life cycle of the project today. Anybody is having any questions regarding this? Quick questions regarding either life cycle or any basics of structural engineering?
Sir, I have some doubts.
Okay.
Sir, how is the core test location? Means we can choose if required.
Which location?
Core test, you said core test we will do for,
Core test.
so yeah, this location,
Gen-
how,
Generally, we do the sample actually, sampling generally. In visual inspection, if you find some major issues regarding the, let's say, column or beam, some beams, whether they are having more cracks or there is some deterioration, if you see in the structure, better to choose those, say, locations mainly. If you don't find anything major, then you can have any sample of the locations. There is no hard and fast rule. We are doing the samples. Say for one floor, let's say, for example, let's say there is one floor. We have one building, let's say like this. So let's say this is our building, ground plus 1, 2, 3. So in each building, you can have, let's say we what members we are having: slab, beams, columns. Okay. So slab, beam, columns we are having in any. So we can have a sample of 3 samples of slab, 3 of beam, 3 of column. Okay. Like that, you can choose floor wise also. Because whatever structural audit we are getting the results, they are indicative and sample results, you can say. See, all of you know that as a doctor, whenever doctor is suggesting any test like blood test, urine test, or any other tests are available, sonography, x-ray, then there are many tests available. They are also sample test. See, nobody is checking each and every part of the, say, body. In the similar fashion, in structural audit, we also take the sample test, which helps the structural engineer to give, say, if the structural engineering is the final responsible person, and he should think like doctors. He has a judgment, engineering judgment he's having, judgment and experience. Okay. And through this engineering and experience, the test will give him added, we can say, justification and evidence for his judgment. So we take the sample test. Now your question is where to, is this the answer of this question, or you are asking some specific regarding the location?
no,
Are you
sir.
asking that it should be center or at the support? Is it the question,
No,
or is this the answer?
What you said is okay, sir. It's okay.
Okay, fine.
Sir, I have another question too.
Yes, definitely.
Like
Please.
we have if we see the deflection while observation, then how is this measured? How we can measure this deflection from the site?
If we see any deflection in the member, how to measure, you are saying?
Yes.
How to measure the deflection? Hello?
By using meters, or is there any specific way to find this deflection?
See, you can use auto level, you can use level tube. All of you know that. Say, there is, let me draw like this. Let's say you have this. I'm just exaggerating the deflected schema. This may not be in reality, but okay. So you can check the level here. You can, all of you know that you can use auto level for measurements. Yes or no? So what I want level here, and I want level at this point. And then you can see that from here to here. So I will check the level at this point. I will check the level at this point, and the difference between the two levels will give me the deflection. So, and what instrument you can use? You can use either, see, do you know that we can use the inverted stuff? This is a stuff. We can use inverted stuff. If you want to check the level in the ceiling level, then you can use inverted stuffs and you can check the level. So you'll put stuff over here first. You will give, say, set one benchmark here, let's say. And after that, you will use the auto level. Let's say now this is not the height. Height will be high actually. Okay, let's say. And you are going to use the auto level like this. And this will be your, let's say, So benchmark at one point, and then you will put the inverted stops, and there is a procedure of using the inverted stop, how to check that RL, backside, foresight, all of you know that. And then their difference, and finally it will give you the level. So this, let's say RL at this point is, let's say 100, 101, let's say RL at this, and RL at this, let's say it is 100.9. So what is the difference between the two? 0.1 meters. Okay. Then you can, this is nothing but your delta. Delta is, for example. Are you getting this?
Yes, sir. Sir, one more
There
thing
is one
related
more
to-
method, level tube. पता है आपको? Do you know the level tube? Water level tube.
Yes, sir.
Yes, sir.
You have know that water is in one level always. So let's say we put water here inside this, so it will have this level, right? We are putting the water in this level tube or water tube. So you can use this also. So you can put some any stick, or we can say tape or stuff, whatever you want, and you check the level here first, and then you check the level here. So you can put two level, दो जगह ये कर सकते हैं. You can put this level tubes like this, okay, and for the same point you can measure this difference, okay. So you can use the level tubes. Any other questions?
सर एज पर आईएस को कितना डिफ्लेक्शन को नेग्लिजिबल कर सकते हैं, इग्नोर कर सकते हैं?
See, it is different for different members, and vertical deflection is having different criteria, horizontal is different. We will see in detail, don't worry.
ओके सर, ओके सर.
We are going to learn that in detail. Where
Sir,
you
I
get-
have one question.
Okay.
Sir, regarding the design part, I have one question. How we know the loads acting on any members, especially the dead load? If we are going to design the member, so first we have to assume the size of the member and then calculate the dead load, or
Yes.
shall we? Because
Assume
That's
is very
what-
much important. Yes, we have to assume first. See, generally the design process or structural engineering is, first of all, structural engineering is approximate science, first of all. So there is no any accurate way of this first. And it is an iterative or trial and error method. Trial and error. So we need to try. Trial means we can say we need to assume something first. Let's say you are assuming one beam of size. In the design, say you got bending moment. So from analysis, you got bending moment. Let's say 100 kilonewton meter. I don't know what it may be. Now what you are saying, let's assume this 230 by 600. Now you will do, assume this size, you will put this bending moment and you will check the design first. Okay. Check the design. And if your this size is sufficient for the design, then you will put the steel into that, whatever is required. So this is an assumption, assuming the size and then checking the design. And you are saying that assuming the loads. So
yes,
There
sir,
is-
the bending moment, shear force.
here how you are getting. Okay.
Yes, sir. This I am asking.
Yeah. So it is a trial error method only. So generally what we do, as per the experience and thumb rules, first of all, we assume the sizes. Let's say in building, this is, let's say this is your span, let's say 6 meter span. Okay. So all these beams are having 6 meter span. So whenever there is a 6 meter span, generally we span upon, say if it is a 6 meters means how much? 6,000. So L by 10, span upon 10. So
Yes, sir.
is the depth. So depth of beam, I will assume 6,000 divided by 10 is roughly 600 mm. Okay. So I will start with this first. That means once I get this size, then I will assume width generally we take the width as 230 mm as per the general practice, we can say. We have the wall loads of 150 mm, and code is allowing more than 200 sizes only for beams and columns. So we will assume 230 mm. It is a standard practice. Once you get this size, then you can calculate the loads. Okay. So what you are doing now, you know the size. Now you will even assume the slab thickness also. So depending upon the span of the slab, you will assume if it is 4 meter, 3 meter to 4 meter, you can say that slab thickness is
150.
let's say 130 mm. Let's say, for example, 3 to 4 meters. So 130 mm to 135 mm, we can assume that thickness. And then once you know the thickness, you can calculate the dead loads. Then what you are doing? So your size of the beam is this. Now you are analyzing that and you will get the bending moments. Okay. समझो यहाँ 100 bending moment है, यहाँ समझो 50 bending moment है. And now what you will do? You will design, this is bending moment, and you will design this size for this bending moment. Okay. So this is your assume size. And this actually you are getting the bending moment through assume size only. So once you get this, and it may be possible that one case is that your size is okay. So for this 100 kilonewton meter, this size is okay. If it is okay, there is no problem. But there is other possibility that the size is not okay, it is not safe. You need to increase the size. So instead of 600, I want 750 by 230 size, because it cannot take 100 kilonewton load. So what will you do? What will happen to this? You will design this for 100 and it is okay, but you have assumed previously as a 600 mm and you have calculated the dead loads using this, and now you are increasing the size. That means the dead load will also increase. That means this bending moment will also increase. So in general, what we do in this case, we again go for the analysis. So see, I have analyzed this by assuming certain sizes, and if I feel that the sizes are less, I need to increase. First of all, increase the size, check for this design first. So let's say if this is taking care of this 100 kilonewton, freeze all the sizes for the bending moments you got from the first analysis. So there is an analysis, first stage, first analysis and first design, we can say. And in first design, let's say you want to revise the sizes or increase the sizes. Once you increase the sizes, again go to the analysis. Again revise those sizes in the analysis, and again do the analysis, again get the bending moments, and again do the design. Okay, so this is the process, cyclic process. Trial error method, we can say. Are you
Okay,
getting-
so got it.
So
Got
you need
it,
to
sir.
do it. Now, see, previously what happens, whenever there were no softwares, manually doing this was a very tedious job. So generally people used to assume more sizes. Better not to do more trials. It is better to assume certain higher sizes and just go ahead. Nowadays we are having softwares, so you can do this in very few minutes. So change the sizes, again do the analysis, again do the design, because we are not doing anything. Software is taking care of everything. So we have to only check. That is our role, checking the design. So how I am going to do that within using software? So I will tell you what. So I will assume sizes as per thumb rules and my experience. Assume sizes of columns, beams, slabs, whatever members are there. I will assume this. Then what will I do? And how I am assuming? Either through experience and some thumb rules. Then I will do the modeling in, let's say, ETAP software as far as the building is concerned. So let's do this model. I'm showing single frame, actually plane frame. We do the 3D model in ETAPs of the whole building, all columns, all beams. I will put the dead load, and see, dead load and is also calculated by the software itself. We are just giving the sizes we are giving. So it will do the analysis. Let's say ETAB is my software. I got the bending moment shear forces through the ETAB software analysis. Now, what I am doing, I am exporting this export to this in the RCDC software. So RCDC, we are having software for design, RCDC software. In RCDC software, once these sizes, it takes sizes from the ETAB only, RCDC software. It will tell you the members are okay or not okay. Not okay. Okay, there is no problem. Not okay, there is a problem. So not okay, what I will do, I will change the size in RCDC itself. Change size in RCDC only and check design, whether RCDC is giving safe design. So it may say that now once you check and it says okay. So you, let's say there are 100 beams and 100 columns. So out of 100, let's say 20 columns are failing. So you are changing the size in RCDC and you are making it safe. Once you do this safe, then you know that my 20 columns, previously the size was 230 by 600. Now it is 230 by 750. Even RCDC gives the log of the change sizes. Once you know that C1 is, I need to change, then there may be C11. I need to change to 230 by 500. Then C32, 230 by. So these are the revised sizes which I want for the design. Once you get this, go here in the ETABS, revise those sizes. Let's say this is my column revised size. This one is then at this point. There may be some point where I want the revision of the sizes. Change these sizes in the ETAB software. Again, go to the RCDC software. Again, do the design. And this is the process. Got it? ETAB to RCDC, RCDC to ETAB. Cyclic. Do till all the members are safe in both the softwares. Okay?
Yes, sir.
Yeah. Any other questions?
Sir, how we decide the position of columns?
Yeah, we will have session on that.
Okay.
Position of column, orientation of columns. We will have that. May I know actually what kind of basics you want so that I will add that in our training part. Say we are taking basics from our perspective, what we feel, but do you have any specific questions that you don't understand? The way that you asked me this question, it was a good question. This one, how to do this? Because assumption, see, this is a really fundamental question. Where to start is a problem in structural engineering. Where to start and where to end, it is really a problem. So whenever you know the starting point, then it is really easy to start our journey. But you don't know where to start, then it is a problem. And as it is an iterative process or trial and error method, then it becomes very difficult. So we have to assume somewhere, then check it again, assume. The cycle is there. So such kind of questions may come in your mind in structural engineering, especially. Any other questions?
Excuse me, sir.
Yes.
Sir, when we check like when we do the reanalysis, that time, if after 15 years or 20 years we are doing that, so in that time, if the codes are already updated, so we will do according to the updated, means we will check everything according to the new updated version, or we will go with the older one.
Yeah, your question is still, it is really. First of all, see, whenever we do the structural audit, or as a doctor, first of all, doctor is first concerned about the life safety. Okay, that is one point. And similarly, as a structural engineer, we are also concerned about the structural safety. See, ultimately, we are concerned about the life safety of the people living in the flats or whatever that structure. See, first of all, in audit, what we do, first of all, you can check the fundamental, you can do the fundamental study. So in this case, fundamental analysis, fundamental design. So fundamentals means, let's say, you can think of the previous code only, let's say, for the time being. See, generally for analysis, we are not using much previous codes, but generally for design, we are using much codes actually. For analysis, generally we use codes of loading conditions, okay? And in design, we are using codes, more codes. And let's say in say building is of 1980, let's say. Building is of 1980. And the code was there in 1980. Okay. So the code of 1980 we are using. You can use this. Ultimately, how the structure is safe. First, I will, as a structural engineering, I will think of the fundamental safety. Now, what do you understand by fundamental safety? That structure should not collapse is my fundamental safety. Okay. So first of all, I will see the stresses, actual stresses I will calculate. I will do the analysis. You can use any code, let's say last time code you can use. Because does it mean that if the code changes, do you think that the old codes, whatever the buildings designed by old code will fall down? Is it so? Hello?
No, sir.
Yeah, so it will not fall down definitely, because whatever may be the codes, any code in any area, time, we can say 100 years back or whatever, today also, any code is taking care of fundamental aspects of structural engineering. They are not violating anything. Now the second question comes, then why the codes are getting revised regularly? See, what we are doing, let's say if your safety is 100%, okay, and apart from the safety, there are certain issues regarding the durability, cost. There may be the other parameters also, refinement of the analysis, refinement of the design. So what we are doing out, so in whenever we revise the codes, 90% to 95%, let's say, safety part is already taken in any code, it may be, and 5% to 10% refinement is there in the codes. So 1980 code was there. If you design the building, it will be safe for long actually. And even though 2002 code is there, you design, it will still stand. As far as the safety is concerned, all codes are okay. But as far as the refinement of the design, refinement of the analysis, refinement of the durability, refinement of the costing or efficiency of the material, here that is playing the game. Okay. And this is not really much concerned in the structural audit, because see, I am much bothered about this area. But okay, as a client, if the client is asking, can you check it for the current code? You can give your comments that for current code, it is not satisfying. Some members are not satisfying for current code. But it may happen that your structure is safe. It may not follow the current codes, but you can say that it is safe structure. So are you getting the question?
Yes, sir. Yes.
So fundamentally, I would say in structures, if I'm a structural auditor, what I will do, I will first of all check the actual stresses, rather calculate the actual stresses. And I will check with the permissible stresses. Now in permissible stresses, all of you know how the permissible stresses are coming into picture. पता है क्या? After using
Through factor of safety.
yes, after using factor of safety. So permissible stresses using factor of safety. So there is a factor of safety used while calculating the permissible stresses. So we are not using the complete capacity of the material. We are giving certain factor of safeties, and then we are checking that, and our actual stress should be less than permissible stress. Okay. So this is in general, and these permissible stresses may differ as per the IS codes. Slight difference may be there in the factor of safeties, little factor of safety changes, or as per the time, but little. But fundamentally, if you see that there is always margin in the permissible stresses, so that actually the codes as per the time doesn't make much difference as far as the safety is concerned. Now I know, so I will just try to give you one example. So why there is a problem in structural engineering? So understanding. First of all, I told you last time that structural engineering is a creative field. First of all, like architects, this is very creative field. I can say structural engineering also is an art. So first, apart from the art and creativity, it is also an engineering. So engineering means we have the laws of physics. We have the mathematics also for the calculations. So structurally, it is also engineering and it is also art. Generally, we have missed this part, art, in our training, rather in our education. So we should combine this art and engineering together. Engineering, we have learned a lot of things. We have learned much mathematics. So we have given more emphasis on the mathematics, more calculations, more this, but we have given almost less emphasis on art, or not, we can say almost. And physics also we have learned, but major focus was given on the mathematics. Now, whenever we say something is creative, all of you know that what is creative? Mostly subjective. Yes or no? Are you getting this subjective or means? Creative means it may differ from person to person, and the perception may be different also for the same thing. So, say as the say architects are designing some buildings, and see, I may like that building or somebody will not like also. Let's say there is a bungalow, very good bungalow he has designed, and if you ask me, I may say I didn't like this. If you ask somebody else, he may say it is really beautiful building, bungalow. Third person, he may say okay, not much good. So it's very subjective answer to every question, or rather to this creativity or this bungalow design. So it's very subjective, means there cannot be an exact answer. There is no logical answer. In the similar fashion, actually, many times in structural engineering also, you will find that there is no logical answer to each and everything. There are some subjective parameters available. So there are subjective parameters. And that's why even though 5 structural engineers are designing, so these are 5 structural engineers and they are designing the same building given by the architect, let's say. So architect has given this structure for design, structural design. Same architect, same building, plan and everything is same. And this is designed by everybody. And you will see that each and every design, structural design is different. So that means there may be subjective, say, opinion for each plan, say, design given by the structural engineers. But if the structural engineers are following the codes and concept basic principles of structural engineering, then all may be right. But there may be subjective opinion for each design. It may happen that this engineer is giving little costly design, but more durable, let's say. He's giving costly, but durability will be very high due to his some ideas in the structural design. This person may give very cost effective, very cheap, but there is a possibility that this person's durability of the building may be very less. He has not considered the constructional part. So this may be the possibility. Yes, from safety point of view, everybody is right. This structure may be costly and but it may be good for construction. So overall construction cost may be good for construction, and the time required for this building will be very less. So he's giving such a suggestion. Time is less. That means every person is giving emphasis on some parameters and he's designing the building. Fundamentally, everybody is taking care of the safety. Codal provisions, engineering principles, safety is there. So these subjective parameters will be there, and that's why there is a possibility that the people like you, as you are taking the training, or there may be some engineers who ask the questions, you may find difficulty in getting the exact solution actually. So exact solution or exact answer. Even though I give you certain answers for some problems, so as far as the creative part is concerned, that is my opinion. How I got my opinion? Through my experience, through my trial and errors, through my judgment. So whenever I give any answer to such kind of questions, these are the parameters which I am considering. But these answers are not exact answers. Try to understand, because in structural engineering there cannot be any exact answer for any question, because mostly the major part is subjective part. So I'll just give an example to you. So now see, you can ask me question then how these people are making the structure as safe. Even though their drawing sizes are different, steel is different, how can you say that it is safe or okay? So I'll tell you why it happens or what is there. So do you know, whenever we assume live load, code is giving live load 2 kilonewton per square meter, living room, kitchen. Okay. How the code has got this number?
Various trial and error or through
Yes,
simulations.
Simulations, then practical, they have tested, they have checked the loads. For example, you know, say let's say take an example of living room. Let me show the plan. See why I'm as you are now working in the practice, so you need to think beyond the theories also. Beyond theories are important, but beyond theories there are a lot of things, so they are also essential. For example, there is in living room, all of you know that there is a sofa. Let's say there is a sofa, there is a teapot, then there is a TV, there may be chairs, then there is a, let's say, TV unit here, then there is a table, furniture, which is hanged to the wall and maybe resting on the floor, teapot. And then as a person, you are there may be 4 to 5%, they are moving here and there, right? all of you know that live load is changing load. Actually, it is not, it may not be there as a dead load, because in dead load the tiles or the concrete slab, it is there itself, or walls. But live load is changing. The sofa today it is here, maybe after 2 years the sofa may be here somewhere. There is a furniture over here, the furniture will be there. Now if you calculate the all loads together, what they have done, actually the load is not uniform. So you see that it is 2 kilonewton per square meter. That means uniform load. And what it is, a uniform load, that means uniformly distributed over the area. 2 kilonewton over 1 square meter. So any 1 square meter you take in this, it is 2 kilonewton, designed for 2 kilonewton for 1. But you will see that here the load is more if the people are sitting on the sofa load plus people load. It will be more here. In the teepot, there is no much load. There is some other space available where there is no load, only dead load is available. Then in TV unit, the wall load is little more, and this furniture is having little load. Sometimes people are sitting here, sometimes people are here, sometimes there are no people. So the load is changing, and still you are saying that uniform load. Okay. So it is actually, we have converted these kind of possibilities into equivalent loads. We means IS code team. And equivalent loads should be such that we can analyze them easily. If you really want to do the actual analysis of, let's say, the one person is sitting or standing over here, one person is sitting over here, then there is one teepot, one TV unit. If you want to analyze such small loads at different locations, it is really difficult and practically not possible, even though in softwares also. So the IS code team has developed the equivalent loads. The equivalent loads are higher loads, conservative side. And again, they have prepared the higher, and so they have assumed higher loads because they are converting them in equivalent load, and they have assumed simple loads as a simple load. Simple means, let's say, uniform load. So they are doing the assumption like this. Why I am doing simple load? Why I am assuming higher? Higher I am assuming because I cannot predict this in exact way. So I am trying to do it higher. Why I am doing uniform load? Because I want to make it simple. Why I am making it simple? Because I want to analyze it. Because I can analyze simple things only. I cannot do the complex analysis. Because whatever softwares are available with us, they can do simple calculations. They cannot do too much complicated calculations. So previously, when there were no softwares, even we used to do still more or higher assumption, because there were no softwares. Nowadays, at least we can think of more accuracy comparatively. So simple things I can analyze, and I can get the bending moment, shear force, and so on. Okay. So this is our case. So the loads which I am assuming as a live load, they are approximate loads. Okay, there is no exact load. See, many times I have seen people fighting to each other. Ki mera samjho, see, one structural designer is saying in the same office, my steel is coming 312. The other person may say my steel is coming 216. Okay, and they are fighting together. I am right, you are wrong, I am right, you are wrong. This is totally a wrong fighting actually. There may be a lot of assumptions done by this person, done by this person. On the basis of assumptions, the answer may be different and still correct. So this 2 kilonewton per square meter is a assumed load, which is not, this is also approximate load. Then this load is even higher. So there was a research done in UK, in journal one of journal. I have seen that whatever loads we are assuming in the code, given in the code, they don't come in their life anytime. This load will not come at any moment in the life of the structure. So they are really on the higher side. Do you know this point? Anybody knows this?
No, first time hear this.
This will never come actually. See, because as these loads are very erratic and we are not sure about it, code has already assumed on the higher side. And even though it comes, let's say this is coming in one room. So there are say 100 flats in the building. Do you think that this load will come in all the buildings at one moment or at one time, for which we have designed the building, for which we have analyzed the building? Do you think that all the loads will be there in all rooms, that to this load?
No, sir.
Just not possible. Not possible. And even the people have done the research on these kind of things. Now you may say that why the code is assuming more loads and this and that. So there are a lot of parameters actually. Whenever you assume certain on the higher side, see, we are giving the factor of safety to the material also, as you know. See, let's say your grade of concrete is how much? M20. That means what is the, this is what is 20? M20 grade. What is this 20?
Characteristic strength.
Yes, characteristic compressive strength. So it is a compressive strength, we can see. Sorry. Compressive strength. Now, whenever we design any column, so this is what is the unit? 20 Newton per mm square is the compressive strength. Actual characteristics means what is characteristics? We are taking cubes. We are testing the cubes, isn't it? Cube of size 150 by 150 by 150. Taking samples, let's say 3 to 9 samples. Let's say I'm just taking samples. I'm testing that in the lab and saying that it is a 20 Newton per mm square. Okay. But whenever I design the column, how much strength I take in the design? Capacity. Do I design for 20 Newton per mm square? Yes. This 20 is we call it as FCK. So how much I design? I generally design 0.4 FCK. Okay. So actual strength I'm designing for 40% only. I'm not taking 100% capacity available. So I'm putting this factor of safety to that. So here I am also increasing the loads in the load IS codes. Whenever I design the columns, I am only taking 40% strength of the concrete. Actually, it is available 20. So the loads which I am assuming, they are approximate. The design which I am doing is also approximate. Then even I do the drawings. Drawings also, there are some errors or gaps we can see in drawings also. Then how I come across approximate load and I do the analysis. So analysis also there are methods. One is doing manually, which is more approximate. One is doing using ATAB, one is doing using STAD, and maybe other softwares. Now within this software also, see, people are having misconception that software gives right results or correct results, or they are very accurate. These words are very wrong. Accurate or correct. That softwares are giving this accurate analysis, accurate design. There is nothing accuracy in structural engineering. It is always approximate. In ETAB also, I need to assume certain things. Assumption of boundary condition, assumption of detailing. Boundary conditions means fixed support, pin support, this and that. Then there are, we are not modeling the structure, real structure. Do we model real structures? Software's real structure model karta hai kya? Are we modeling real structures in softwares? Question समझ में आया? Hello.
Yes, sir, we can hear it, but up to what extent it mean real structure? I didn't
See,
get.
real structure is real means whatever structure constructed on the ground. I will go. I will take that structure. I will lift the structure and I will put into the lab or whatever. So I am analyzing the real structure or I am checking. It's not possible, right? So what I am doing, I am doing the mathematical model of it. And when I say mathematical model, it is a model. It is not real. And whenever I do any model, there are assumptions. Again, assumptions in modeling also. For example, I just will give you one example. Say this is your, let me show you this is my beam. Oh, sorry, column. Let's say this is my column and this is my column. This is a horizontal column. Let's say this is a big square column, let's say. And then I have beams. These are my beams. And I have a slab. Okay, so whenever I model this in this is my real structure, this 300 by let's say 600 size of the column and this, and then thickness of the beam is also 300, let's say. Okay, so whenever I model this, rather if I want to model this instead or say ETABS, let's say this is my 4 meter out to out. Real dimension I am talking as per the drawing. This is also let's say 3 meters. Okay, so this out to out is 3 meters, this out to out is 4 meters. But in mathematical model in softwares, I cannot model the 3-dimensional structures. I can model, see this beam, I can model as a line element. You're going to learn that in say software training. So I can model this beam using line only, line element we can say. That means I cannot model thick or solid element. So for what I want, I generally do the assumption that I will assume 1 point over here in the center. I will assume 1 point over here, and then I will, this is my line. Then again at this point I will have this. Again this point. We will learn that in software training, how to model then this point. And in software actually we see only lines. So if I see in ETAB or whatever software, I can see these nodes, points. I will see this line. Okay. And see, we have done manually also. We have analyzed the mathematical models only. Whenever I say that this is a frame, I show this as a fixed support and this is my frame. Actually, and I'm analyzing this, I'm putting the load on this and then I'm drawing the bending moment like this, right? So this is actually line element. Is this a real structure? No. A real structure looks like this, which has a depth, which has a width. Actually, real structure is like this. Okay. Having thickness. This thickness is there, but actually I am modeling as a single line element. Similarly, in softwares also, I model this as a single line element. That means my real dimension will be less. If this point to this point distance kitna aega mera? Less than 4 meter aega na? Let's say 3.9 meter. Just take an example. And this dimension will be, let's say 2.9 meter. I'm just taking an example. So real outward dimension is 4 meter. but you are modeling 3.9 in software. So you have started the errors or issues regarding the accuracy. You started here itself, isn't it? 4 meter real में है तो आप तो 3.9 कर रहे हैं, and you are modeling that in ETAB, and you are doing the analysis of such a structure, and you are saying that I am doing the accurate analysis in the software. Okay, is that really the case? Hello, do you
Yes,
think
sir,
the
no.
softwares are giving accurate results? So the accurate word itself is wrong in structural engineering. Don't use anywhere. Don't use manual calculation. Don't use for softwares also, because we are working in an approximate science, which is very subjective, which is very creative and artistic. So it is better just that you start somewhere, check whether the design and other assumptions are okay. So finally, what we are doing in the structural engineering, that whenever you start anything, where you start by assuming something. Okay, you are starting by assuming something. So assumptions is very important word in the structural engineering. Assumptions. So assumptions में क्या आएगा समझो. See, I am assuming the load as 2 kilonewton per square meter. Okay, whenever you assume this load, you should be 100% sure that your load will not increase than this in any time of the life of the structure. Then and then your assumption is correct. So let's say this living room is there and you assume 2 kilonewton per square meter load. Whenever you assume this, you should be confident enough in that. Now there may be second structural engineer that he will say, I don't want to take a chance. Let's assume 3 kilonewton per square meter. I don't know whether it will happen or not. Now this person is also right, but he is assuming very high number, which may not come in the life of the structure. Only he is giving this number due to his fear or due to his lack of knowledge or experience, I would say. Because he is not having experience, so he is afraid, and he is afraid, that's why he is taking higher loads. I know that he will give the safe design, no problem, but it will not be cost effective suggestion. So the person who assumes correct loads, which will make the structure safe and cost effective, durable, serviceable, and so on, lot parameters. If his assumption is taking care of all these parameters throughout the life of the structure, then his assumption is really good assumption. So what happens whenever you get the experience in the field by doing lot of practice and projects, your assumption becomes very strong. कि क्या assume करना है. Otherwise, okay, software will help you to do the iterative analysis, but apart from software also there are other assumptions. So how we are working in structural engineering, we are assuming something and we are checking the assumptions, checking its validity, whether it is valid or not. So checking the design, checking the loads and so on. So there are a lot of parameters we assume. So totally structural engineering is based on the assumptions, and we analyze the assumptions. Okay, we are analyzing the assumption, we are designing on the basis of assumptions, and we are every time we are verifying the assumptions, whether our assumptions are in line with the total life cycle of the projects. So whatever assumptions are there, they should be in line with the life cycle of the project. And life cycle is having analysis, it is having design, it is having drawings, it is having real site construction, it is having even after the construction, throughout the life, it has to stand. So this life cycle total, whatever activities are involved in the life cycle, and your assumptions you assumed during the planning, they should hold good throughout the life. Now in structural engineering, please focus on this point. This is very important point. I know that this is very subjective point. Now you will not have any exact answer to the assumptions. Many times people ask me, say questions, what to do for this. The people note it, ki, okay, aise karna hai. So in college, what we do write down the steps: step 1, step 2, step 3, step 4, and finally I get the answer. So if this is the problem, if I know these steps, I will get the answer, and this is the step. But it is not always possible for all kind of problems in the structural engineering. You need to even give your creative thoughts on that. You need to assume certain things, verify this, and then you can get final answer. Don't worry regarding this, as this part, even many experienced people still find it difficult to understand these things many times, because it is so continuous process that understanding these things also takes a lot of time. But don't worry, in our training program, we are going to learn a lot of that simpler ways also. At the same time, you should know the reality also. ऐसे नहीं होना चाहिए कि ट्रेनिंग प्रोग्राम है तो इतना ही है and then you become 100% structural engineer. No, it is not the case. But yes, definitely it will open your eyes and will give you the basics required to understand the subject. And the total process will be clear. That is very important. So you will not learn the part, you will learn the whole. And there may be possibility that detailing part is still remaining. You can continue that throughout your career. Okay, any questions? Did you get me what I tried to discuss with you?
Yes,
As
sir.
it was
Yes.
very subjective point, but still,
Yes.
Yes, sir.
yeah. So, see, it is really easy to teach you the, let's say, ये bending moment इतना है मेरा 100 kilonewton. Say, then B is equal to 230, D is equal to 600. फिर I will use one formula, AST is equal to this, what that 0.5 FCK upon this and that. My formula, then calculate AST minimum, then calculate shear stress. And this is very easy to teach actually. But many times these types of questions, it really requires deep thought, little experience and lateral thinking. Then these kind of things can be understood. But I would suggest if you learn these things in our training program, it will be a really great experience to all of you. Because learning these steps of calculation, manual calculation or theory, whatever we learn in books is really easy because they are very straightforward problems. But these things will develop your lateral thinking, whatever I told you today. And this will really start your creative part of the structural engineering. So ये बहुत important है. But it is not one day job or 1 month job. It is a continuous part. So whenever you get any questions, please ask. Through that, it will be clear. So actually, hence onwards, we will start our basic concepts of structural engineering from the next session. But whenever we learn the basics, we are going to learn in a different way. So as I said you, that structural engineering is approximate. Science. And I am going to give you or teach you the approximate concepts of basics. Okay. Approximate basic of structural engineering. Now, why to learn approximate? Why not to learn detailed? Is a big question, isn't it? Somebody may ask me, कि approximate क्यों सीखने का, detail क्यों नहीं सीखने का? Anybody answer me this question? Why not detailed?
Because all the problems are not unique. That's why.
Yeah, that is yes, one good answer. All problems are not unique is one answer. Non-uniqueness, let's say. Any other? See, why to learn approximate? Because approximate is simple. It's very fundamental answer for this, because why we are learning why we will learn approximate, because it is very simple, and simple things only we can understand. So human brain can understand only simple things as far as logic is concerned, as far as engineering or science is concerned. It can understand only simple things. It can calculate simple, it can understand simple, but through his intuition, through his subconscious mind, it can ultimately tell you something is wrong or right. That is, see, brain is having great power. Brain and our subconscious mind, I would say. Brain is generally used for the calculation and all other things, but there is some subconscious also involved in that. So these two together is having power, but subconscious cannot solve the complex problems, complex logical problems. If I give you the, say, calculate this dabba by dabba x of 3x square into e raised to 2x minus 2, and this kind of we have learned in the maths M1, 2, 3, such kind of, and I ask you, please solve this. Maybe I will give you some more sigma 3x square upon. If I give you, will you really give me the answer to this?
Of course not.
Not possible. So we have learned that Fourier series and so many things in maths. Why we cannot give the answer? Because it is really not simple to understand for the brain actually. If you want to understand this, I'm not saying that is really not possible, but not in one attempt. Brain cannot understand ye kya hai. See, it will be like Tare Zameen Par. You might have seen that movie, Tare Zameen Par. That the child is not understanding, that kid, whatever the teachers are telling in the school, classroom regarding maths and other things. But yes, I can understand. So what I will do, I will first of all simplify this complex equation. This is a complex equation, and our brain cannot understand because it is very complex. So what I will do, I will simplify. First of all, I will try to understand ye dabba by dabba x kya hai, I don't know. Try to understand this separately. Then what is 3? Okay, 3 is a number. Then you can know if these are the 1, 2, 3. So this is a number. Simplification of these 3. There are 3 objects, 1, 2, 3. So this is nothing but a 3. Then there is a x square. So x square, what is x? If you look at the x square, what is in front of you? It is a function. Does anything comes in your mind whenever you see this function x square को देखने के बाद कुछ समझ में आता है क्या आपको? अगर नहीं आता तो फिर हम एक काम कर सकते हैं. Is a function. First of all, you know it is a function. So let's draw this function on the graph paper. यहाँ मेरा x square है समझो, यहाँ मेरा function है y. Okay. So if I put the numbers, समझो एक ये 1, 2, 3, 4, 5. So x square. So 1 square is 1. So यहाँ 1 है. 2 square is 4. ये 4. Okay. So 2 square ये point. 3 square is 9. 4 square is 16. मतलब क्या हो रहा है? ये ऐसे कुछ तो ऐसे जा रहा है. Right? Isn't it? This is a parabolic graph. Parabola. Right? That means something is changing in this fashion. Is the meaning of x square. This is a partial derivative. Okay, that we will go. Then something is exponential. Whenever you say exponential, it is also some kind of exponential graph is like that. So you see that something starts very little flat here and then again it goes like this. So that is the meaning. So what I did, instead of getting scared, looking at the equation, I first of all tried to simplify each and every parameter and term into that in my understanding way. This I can understand. I can visualize this x square now. Only x square I cannot visualize. It is only, we can say, Greek number or mathematical number, and I don't understand that. But if I say, because I can visualize through this, I can visualize this e raised to x. Only e raised to x is nothing, no meaning to me, because my brain cannot understand what to. But yes, my eyes can see this. My eyes can see this graph also. Now I can understand. I can see this 1, 2, 3 numbers. Then I can say that this is nothing but 3. So this is, if I make it simple, then I can understand. And you will see in structural engineering, if you understand approximate science regarding the structure, it may be approximate analysis, approximate design, drawings, whatever, then you can understand the whole subject, whole understanding. You can say whole subject understanding. And once you understand the whole subject, then you can solve any structure, any type of structure in the world. कुछ भी कर सकते हैं. And that is the power of approximate analysis. Now you will say that whether detail is required. Yes, detail is required. But I am suggesting to focus on this first, maximum possible, because this is going to be with you throughout the life, because it is, your brain can understand this only. For this, you cannot understand, and this will not develop the understanding. Understanding यहाँ develop होने वाला है approximate में. So your understanding will develop in this process. In this process, it is required because the codes are given. There are mathematical calculation, equations, stiffness matrix, and this and that. Lot of things are there. Whatever we learn in the engineering, I need to refer this. ये करने के लिए मुझे refer करना है. But whatever detail calculations I am doing, if I want to check this detail calculation, check करने के लिए मुझे approximate calculations पता चाहिए. Because if I am convinced with the approximate things, then I will sign this. Okay, it is okay. For detail calculation, you need to refer the books, you need to use the softwares, you need to use the detailed procedure of calculations and so on. So whatever we learn in the books and whatever you will learn in the softwares, that is nothing but detailed. But approximate will give you the understanding, the judgment, the right decisions in these projects. And that's why we are going to focus much on this part in the basics. Okay. So I think we should conclude today's session. Did you get this?
Yes, sir.
Yes, sir. Yes. So in basics, we means it is included how to draw the bending moment diagram and shear force diagram for each.
Also, yes, we will cover that.
Okay.
So whatever we have learned in engineering, but the important aspects which will help you, because total engineering cannot be finished, but okay, simple things which are really required, like bending moments, how to draw, how to calculate, then what is the meaning of bending moment diagram, how we are using for the design, what is force, what is pin support, fixed support. So all these kind of basics which are practically required, we'll cover. Okay, so shall we conclude today?
Yes, sir.
Okay.
Thank you, sir.
Thank you, and good
Thank
night
you,
to
sir.
all.
Good night, sir.
Thank you,
Night.
sir.